Pandemic flu is one of the biggest threats facing humankind today. It has claimed millions of lives in the last century alone, and experts say it's only a matter of time until the next one strikes. When this happens, no one will be immune to the illness, and the outbreak will be explosive, spreading across the world. Many of you are probably wondering how this type of flu is different from the flu that spreads each year during the winter, giving you a cough and a runny nose. Both illnesses are caused by highly related influenza viruses, which is why they are both called flu. A few changes in some of its vital characteristics make the pandemic influenza virus so much more deadly.
Throughout the last 100 years, a number of flu pandemics have wreaked havoc on the world. First, we go to 1918. Around the end of the First World War, a devastating disease swept the globe, infecting 500 million people and killing 50 million, more people than were killed in the war. This disease was Spanish flu, the first and most deadly influenza pandemic of the 20th century. Almost 40 years later, in 1957, the next flu pandemic emerged from China, closely followed by the third and last flu pandemic of the 20th century in 1968. Pandemic influenza did not strike again until 2009. Swine flu originated in Mexico and then spread to the rest of the world through global air travel. The impact of swine flu was much less severe than past pandemics. The worldwide death toll is estimated at just under 300,000. So, where do these pandemic viruses come from?
We get pandemics when a brand new virus from an animal source, usually birds, crosses into humans and becomes transmissible between us. And the reason that causes a pandemic is because the outside of the virus looks different to our immune system than any of the viruses that are going around in the wintertime as seasonal flus.
The outside of the influenza virus is made up of two proteins that sit on the surface of the viral particles. One of these proteins is called hemagglutinin, of which there are 16 different types. However, only 3 types, H1, H2 and H3, have caused pandemics in humans. The other protein is called neuraminidase, of which there are 9 different types.
Each flu strain is named after the type of hemagglutinin and neuraminidase on its surface. A virus with hemagglutinin type 1 and neuraminidase type 1 would be called H1N1. One of the most important ways that a new strain is produced is through the process of antigenic shift. Each influenza virus particle has 8 pieces of genetic material inside it. Antigenic shift can occur when an animal, often pigs or poultry, is infected with 2 different strains of flu. If the 2 strains infect the same cell, then their segments of genetic material can get mixed up, producing new strains of flu. Some of these new strains might be able to cause pandemics if they have a combination of hemagglutinin and neuraminidase on their surface that no one has been exposed to before. However, even if a new flu strain manages to jump from an animal into a person, this will not necessarily spark a pandemic. Bird flu strains are adapted to infecting birds, not humans. These viruses have to change or mutate to be able to copy themselves in human cells. But in China, there are outbreaks of 2 strains of bird flu, H5N1 since the late 1990s and H7N9 since 2013. These viruses have mutated so that they can replicate in human cells. However, they still haven't sparked pandemics. This is because they are missing one crucial element.
They cannot be passed from one person to another very well. For a flu virus to cause a pandemic, it must transmit efficiently between people through the air so it can spread across the world. So how are we preparing for the next pandemic, whether it be H5N1, H7N9 or another flu strain that we haven't seen before?
Around the world, there are many labs working on flu strains that could cause pandemics, attempting to understand why certain viruses become pandemic and others don't. Other researchers have gone a step further and have actually made a pandemic flu strain in the lab. Many scientists have warned against creating such dangerous strains, saying the small risk of escape still outweighs the benefits of such experiments.
There is always a chance that a virus could be released from a lab. I think the chances that route will be the next pandemic versus the chances of the billions of viruses which are present in nature and are reassorting and evolving all the time in different hosts it's, again, if you think about it as a numbers game, the chance is minuscule.
Meanwhile, other scientists are constantly searching for the next pandemic flu virus in the wild by looking at wild birds, farmed poultry, and people in high-risk areas.
So surveillance, of course, is key, out in places like China and other parts of Southeast Asia, where people come into contact with large numbers of live birds that might be carrying flu, there is good surveillance in the wet poultry markets these days, but it can always be better.
But even if we can detect exactly which flu strain will cause the next pandemic, do we have any way of controlling it? Currently, vaccines are designed to match specific flu strains. If these types of vaccines are going to prevent the next pandemic from spreading, we need to make vaccines faster and get a lot better at predicting which flu strains will become pandemic.
The other school of thought is that we give up on that and we go down the route of trying to develop universal flu vaccines, which work in a completely different way. And everybody's very excited about that at the moment, but they are a long way off, and we don't really understand exactly how such vaccines would protect people and how to induce that right sort of antibody.
Although we cannot fully predict when, where, or what the next influenza pandemic will be, we can try and best prepare ourselves before it strikes. This includes formulated plans of action and increased research and development into drugs and vaccines. However, it's impossible for us to be totally prepared for when the next pandemic hits. Only time will tell just how infectious and deadly the next pandemic influenza virus will be.